Okay, example number 6 is our last example for section 9.2, part 2, and it is a difficult one. This is a very, very difficult question. Be very, very careful with all of your algebra the whole way through. It is really hard to get the right answer. So let's look at this one. So the sides of a nuclear power plant cooling tower form a hyperbola. The diameter of the bottom of the tower is 280 feet. So down here, we've got 280 feet. The smallest diameter of the tower is 164. So crossed here, which is 435 feet above the ground. The tower is 600 feet tall. So the question, I can't fit all of it on here very good, so I have to go down here. So find the width of the tower at the height of 208 feet to 1 decimal place. So we want to know what the width at a height of 208 feet is. So let's change colors here. I'll put this in a blue. So what we want to know is at 208 feet, so let's say that's going to be our blue line. So this is going to be a height of 208 feet. We want to know what the total width is. Okay. So one thing that'll help us in the end to make sure we get the correct answer the first time is if we put, let's use a variable u here. And then the answer that we want, the width, w equals 2u. So that's one thing that will help us, is because the answer that we are going to get is going to be just this half, which is u. So let's call that width is equal to 2u. Okay, now we need a new color. Red is already on there. Let's use purple. Okay, so this width right here, 164, this is where it says it is the smallest diameter, the smallest width across. So this is where we are going to place the center of our hyperbola. So if we say this is the center, we're going to center that at 0, 0. Then we can start to pick apart a hyperbola and an equation for that hyperbola. So let's put, okay, so this is one branch of our hyperbola there, another branch over here. Lovely. Okay. Then we know this distance here from the center to one of the vertices is going to be a distance of half of 64, which is going to be 82. So we're going to have a vertice at 82, 0. And this other one here would be at negative 82 and 0. And so that'll give us our a value. So our a value must equal 82. Yes, a value is 82. So let's start. So we know this opens left and right. So our x terms are going to come first. We also said that it's centered at 0, 0. So x squared over a squared, which is going to be 82 squared, minus y squared over b squared, which we do not know what that b squared is equal to 1. So now we're going to have to pick out some other information that they have given us in here, and see what we can figure out. So let's see this blue line right here. This is what we want to find. But they also tell us that 435 feet down to the ground is a total width of 280 feet. So let's look at this on our coordinate plane here. So this comes out and meets our hyperbola, and that point, if this is 0, 0, then we're going to go to the right 140 units, because that's going to be half of the 280. That's going to be our x value. Our y value is how far we came down from the center. So we come down 435 feet to get to this point right here. So that gives us an xy point. So let's plug that into our equation and solve for b. I'm going to write over here and then erase that, because I'm going to need lots of room. So we've got x squared over 82 squared minus y squared. And I'm going to leave these numbers as just being squared for as long as I can. I'm going to even work through my calculator with these because they're really big numbers. You're going to get some really, really big numbers. And I don't want to estimate very much at all. I don't want very much of a rounding error because we're only going to one decimal place. So we don't either round way out 3 or 4 or 5 decimals, or just leave everything in terms of squares as you work out through the whole problem. Okay, so that's what we had. Now what we're going to do is plug this 140 and 435 in for x and y. So now we have, let's do that over here. We'll have room over here now. Okay, so now we have 140 squared over 82 squared minus 435 squared over b squared, which equals 1. So first thing I want to do is I want to get rid of my denominator. So I'm going to multiply everything by least common denominator, which is going to be 82 squared b squared. So when I multiply everything by that, there we go. Come on, my pen. Okay, so multiply everything by our least common denominator, which is 82 squared b squared. Okay, now on our first term, the 82 squareds are going to cancel, and we'll be left with, oh, that's worse. So I'm trying to get my pen to work better. Okay, so we'll have 140 squared. There we go. 82 squareds will cancel, so we'll have 140 squared b squared minus 435 squared. Now on this side, the b squareds, for this term, the b squareds are going to cancel, but we'll still have to multiply it by 82 squared. Now if you multiply those two together, you're going to get a really big number, so just leave them like that. And then on the right hand side, we will get 82 squared b squared. Because nothing cancels out, we just multiply it all by 1. So we're not going to multiply out that 82 squared either. So I'm going to do a couple steps in one here. I'm going to subtract 82 squared b squared from both sides. Then I'll have like terms together over here, and I can simplify those. And then I'm going to also add the 435 squared times 82 squared to the other side. So we get 140 squared b squared minus 82 squared b squared equals 435 squared 82 squared. Okay, multiplying those. Okay, so let me make sure I've got this right. So 140 squared minus 82 squared is equal to 12,876. So 12,876 b squared. And then that's equal to 435 squared times 82 squared. Okay, now solving for b squared, we've got 435 squared times 82 squared all over 12,876. Okay, so now we should have b is equal to, and you can leave that as b squared also. Let's see, I had b is equal to, I do like to find b because I can estimate and know that what things look like. So if b is equal to 314.349, that would be how far we would come down. So we could estimate that right about there to put in our construction rectangle. And I think that looks pretty good. If I had our construction rectangle there, oh, like that, yeah, and my hyperbola's there. Anyway, we know that it's going to be before the 435, so that's a pretty good estimate. As long as it's not something really outlandish, we should be good. Okay, so that is my b value. So now I need to rewrite our equation. So I'm going to come over here. Now that I know exactly what my equation, ooh, that is not what I wanted. Come back. Whew. Just want to erase that. Oh, erase. Okay. So now I have x squared over 82 squared minus y squared over b squared, which I am going to put the b squared value in there, well, because I think it's a better estimate. We can put in the 98, was 98,815.54 equals 1. Or you could put it in as 314.349 squared is good too. That might be, well, it's a little less to write anyway. Okay, so now we are done with everything on this right hand side. I'm going to erase all of that, and then we will be able to figure out the rest of our answer. So I'm going to pause here for a second so we don't run out of time. Okay, and now we are ready to figure out what the information in blue is here that we wrote. So in the blue we can mark a point here that is on the hyperbola, and I want to know what point I can label that as. So that is the distance of u away from the center. So my x value is going to be u, that's what we're trying to find, and then that is going to be a distance for y. It's going to be negative, well, we know from the ground it's 208 feet. I knew that, it's down here, I didn't have room to fit in the whole question, but it says at a height of 208 feet. So I need to know what the distance from the center is, so I'm going to do 435 minus 208, which was 227 feet. So really that would be a negative 227, but when I put this into the equation and square it, I'm going to ignore that negative because I know negative 227 squared is the same as positive 227 squared. Okay, so let's go ahead and plug that in. So we're going to plug in a u for x. So we've got u squared over 82 squared minus y squared. Nope, not y. We're going to plug in 227 for that. 227 squared over our 98,815.54, and that's equal to 1. Then we have u squared. We're going to multiply everything by the least common denominator, which is going to be the 82 squared times 98,815.54. When we multiply by least common denominator, 82 squared will cancel, and so we'll have that times 98,815.54 minus 227 squared times 82 squared is equal to 82 squared times, I'm going to run out of room here, times the 98,815.54. That looks horrible. So now I am just going to go ahead and solve all of that. On my calculator, I'm going to keep this as 82,000 times 98,815.54, and then add all of that together and divide. You could do all that all in one place, or at least just keep a running total on your calculator so you don't have to write those numbers. They really are big numbers. So I'm going to pause here real quick, get u squared, almost out of time. Okay, I'm almost out of time here, so I went ahead and finished the problem. So solved all of that, multiply those two big numbers together, add 227 squared times 82 squared, then divide all of that by the 98,815.54. You get u squared is equal to 10,230.31103. I did not round that at all. Take the square root of that. You get 101.145. Remember that that is just u. That is only half the width. So I took that width, multiplied it by 2u, and, well, anyway. You know what I meant. Took u, multiply it by 2, 202.34